Hey, welcome. What did the baby corn say to the mama corn? Hey, where's the popcorn? Oh, yeah. All right, guys, we're writing inequalities. And this is, even though your cover sheet says differently, this is going to be the last video in this unit, okay? We're going to actually skip the very last part of this unit, just one video. And your I can statement is to write an inequality that matches a situation, to answer questions about that situation. In other words, I want to give you some possible real world scenarios. Now, I realize some of these word problems, you're like, really? Why would anybody do that? But they could happen. It's possible in the real world. And given those scenarios, can we write an inequality to help us think through the problem, think through the question? And so there's just two examples. It's one of those things that's hard to teach because it's how you think. And so I'm relying upon all the stuff we've done this year to help you think mathematically, okay? But I'm gonna give you two examples. All right, here's the first problem. Remember, the first step in word problems is to not freak out. Second step is to read it. So Tom has $6.50. That's how much he has to spend. So I'm gonna underline that because I think that's important. On lunch, he buys a burger which costs $3.25 and wants to get a few cookies. If each cookie costs 75 cents, how many cookies can Tom buy? Explain your thinking. Write and graph the inequality you created to answer this question. So there's a lot that's being asked of us, a lot of questions, there's a lot of information. So we're going to take it one step at a time. First thing I'm going to do is I'm going to kind of put in parentheses the first question, and that's what I'm going to focus on answering first. Then, once I figured out an answer to that, I'm going to take care of these other requirements. I'm not just going to answer it and move on and pretend like the question didn't ask me to explain my thinking or write and graph an inequality. I'm going to do each one of those things, but I got to start somewhere. So if Tom has $6.50 to spend, whoops, my marker's doing some weird stuff. Okay, if he has $6.50, I want you to imagine this. He wants to go buy some food, right? He buys a burger, which costs just one burger. Notice the word A, just one burger. So he has a one-time expense of $3.25. But then he wants to get a few cookies. We don't know how many cookies he wants to get, but we know that each of those cookies costs 75 cents. So I'm going to write something here, and I just want to talk about it for a second. All right, I've just written an inequality. That sounds kind of hard to see. Let me explain how I derived this inequality or how I created this inequality, okay? Some of you guys probably already see it or you've created it faster than I did. But on the right-hand side, on this right-hand side, I put the amount to spend. Okay, the amount that he has to spend on lunch. And I know that that has to be greater than or equal to everything that he spends because you don't want to spend more than you've got. So that means everything that he spends needs to at least be equal to or less than the $6.50. On the right-hand side, all this stuff, I put his expenses. I'm describing his expenses, right? Here's the one-time burger, and here's the cost per cookie. So now I've got a two-step inequality that I can solve for C with and figure out how many cookies he could buy because it asks you how many cookies can Tom buy. So you may have already imagined this. The first step is to subtract 325 from both sides. And some of you guys may not have even thought to do an inequality because you may have just thought this through in your own mind. Oh, okay, if he has $6.50 and he buys one burger, let's just subtract that and see how much money he has left. Well, that's really all we're doing here. I just set it up an inequality to help me do that. So these go to 0, and I'm left with 75 cents times the amount of cookies he's going to buy. C does not stand for cents, by the way. It stands for the amount of cookies. And then I do my subtraction here. Okay, so 650 minus 325. Remember, I got to borrow for this 0, so I'm going to turn that 5 into a 4. Okay, and I get $3.25. Now, after you figure out how much he has left, it would make sense to divide by the cost per cookie to see how many cookies could be purchased. So that makes a whole lot of sense. So I'm going to divide both sides here by 75 cents. And as it would turn out, that actually gives us an answer for C. So this is a little interesting, though. I got to do this division. And you know what? Instead of setting up a division problem for this, like, I could put 3.25 under the roadway and 75 outside the roadway. 75 cents. Move the decimal point twice in both answers, or both numbers, excuse me. So I get 75 into 325, right? I could definitely do it that way. And that'd be a fine way to do it. Oop, Let's see if my eraser will work. The reason I'm not going to do it, though, is I think we can do this mostly with mental math. Okay. Let me show you what I mean. It takes, I know right offhand, it takes 275 to make 150. So we're talking about 75 cents, right? So I can do repeated addition to see how many 75s will go into 325. So I know 75 plus 75 plus 75 plus 75. I just know this off the top of my head will equal 3. Okay, and then there'd be 25 cents left over. If you didn't know that off the top of your head, like if you didn't know that 75 plus 75 was 1.5, and 1.5 and plus 1.5 was 3, then you could just do the actual division, which is what I'm going to do now. But you know, when you come across problems like this, sometimes because it takes time to divide decimals, it's actually easier if you just do it in a different way. Use whatever strategy comes easy to you. So I think I already said that I know that this is going to go in there 4 times, and 4 times 75 is 300. Okay, and if you didn't know that, you could have guessed and checked. There's 25 left over. So I can actually keep this going and bring down a 0 here to get an exact answer. So 75 will go into 250. Let's see, how many times would that be? That would be 3, I think. Let me double check that. 3 times 5 is 15. 3 times 7 is 21. 225. So I got 25 left over. And it looks like we're going to get a repeat on the 3. So C is less than or equal to 4.3 repeating, right? So I did all that math to figure that out, but he can't buy part of a cookie. So in this context, Tom can only buy 4 cookies, right? Because C has to be less than or equal to 4.3. So in other words, he has enough money left over after this burger to buy 4 cookies, okay? Now, it said explain your thinking. So what I would have written, something that I might write on my sheet would be, I know that Tom can buy, up to but not more than 4 cookies, because then I would show the inequality that I created, solve it for C, and show that C is less than or equal to 4.3 repeating. And then I would say, you can't buy part of a cookie, so because of that, Tom can only buy up to 4 cookies. That would be a great explanation. And then I would actually graph this inequality. Now, you could graph this inequality as C is less than or equal to 4.3, or you could graph it as C is less than or equal to 4, because you may want to round to the nearest whole. And so actually, all this division here was kind of silly. Like, I didn't really need to keep going. I could have just stopped at 4, because I know that you can't buy part of a cookie, which is fine. So I kind of made it a little harder on myself. So not only did I answer how many questions, or the first question of how many cookies can Tom buy, we explained our thinking, and we solved this inequality, which I could graph it, but I know you guys know how to graph. There's just one more problem I want to do with you. Sally owns a dog kennel service and likes to keep at least 15 pounds of dog food per dog she is watching on hand. Okay, that's worded in kind of a weird way. But in other words, for every dog she watches in her dog kennel, she wants 15 pounds of food available. She's currently watching 21 dogs and has 330 pounds of food. Does she have enough? Explain the reasonableness of your answer. Again, I think I want to set up an inequality. So if she has 330 pounds of food, we want that to be greater than or equal to 21 times however many dogs she has. Oh, I'm sorry, I wrote that incorrectly. We want that to be greater than or equal to 15 times however many dogs she has, because we want 15 pounds of dog food per dog, okay? It tells us right away how many dogs she has. She has 21 dogs. So she would need 15 times 21 pounds. So if this inequality is a true statement, then we know she's okay. If it's a false statement, then that means she has more desire for food, or she needs more dog food than she currently has. So this number represents her current supply. And this number here represents, what she needs, her needs for her dogs. So if we do this inequality, 15 times 21, if we actually kind of just see if it's true, 5 times 1 is 5, 5 times 2 is 10, 1 times 1 is... Okay, so we do this math here. We get 315. So that means she only needs 315 pounds of dog food, and she has 330, and 330 is greater than or equal to 315. Because of that, she does have enough. So my answer would be yes, but then I would put a comma or a period and write a new sentence explaining the reasonableness of my answer. And in that explanation, I would say, I know she has enough because 330 is greater than 315. And she needed her supply to be greater than or equal to her need of dog food. That's one explanation I could give. Guys, there's a lot of problems, excuse me, not a lot of problems, but there's a lot of variability in the problems, meaning one problem is going to be different than the next. And the only thing that you can do is try and solve these using your best thinking strategies, okay? There's not one right way to solve these problems. I've just shown you some of my thinking. But if you think about these differently and you've got an easier way to solve them, do it. I don't care. That's fine. All right, guys, good luck. Oh, wait, before I go, there's a number clue. There's actually a lot of number clues here because this is the last video. So I put 3 clues in one. So if you want to pause it and write those down, I'm going to sign off here.